All right, in today's lesson, we're going to take a look at mutually exclusive and overlapping events and how that can be incorporated in calculating probabilities. So, the concept of mutually exclusive events means events are mutually exclusive when there is no overlap. So, if the intersection of the two sets is empty, essentially. So as it says here, if they cannot both occur in the same trial, okay? For example, flip a coin, it lands on heads or tails, therefore the events are mutually exclusive. It's impossible for a coin to land on heads and on tails at the same time. In example A here, let A be the event that you roll an even number on we have a 12-sided die, a dodecahedron, so it's got the numbers 1 through 12 on it. And we want to find the probability that you roll a even number or a 7. Okay, so if A is the event that you roll an even number, then A is going to have 2, 4, 6, 8, 10, 12. Let B be the event that you roll a 7, and there's no overlap. There's no numbers that are in both sets. So we can also list it this way. A is 2, 4, 6, 8, 10, 12. B is 7. There's no overlap, so they are considered mutually exclusive events. So when we calculate the probability of A, our sample space, so this is a number of elements in A over number of elements in our sample space, and so our sample space is the 12-sided die, so that's 12. There are 1, 2, 3, 4, 5, 6 items in set A. B has 1 out of 12. And so to calculate A or B, we would do, this has 6 and this has 1, so that would be 7. So the probability of A or B would be 7 out of 12. And then if we calculate probability of A plus the probability of B, probability of A, we said, is 6/12 or 1/2. Probability of B is, in fact, I'm just going to leave this as 6/12 because it'll be easier to add them. Probability of B is 1/12, and when I add those, I get 7/12. So what we want to notice is that the probability of A plus B is the same as the probability of A or B. Okay, so when events are mutually exclusive, or just simply means addition. If you want the probability that event A happens or event B happens, you just add the two. And so that's what we see on the next page. When events are mutually exclusive, the probability of A or B happening is the probability of A plus the probability of B. So now we're going to look at what happens when we have overlapping events. Again, let A be the event that you roll an even number. So A is going to contain 2, 4, 6, 8, 10, 12. Let B be the event that you roll a number greater than 7. So B is going to be 8, 9, 10, 11, 12. And so in the Venn diagram, we would have 2, 4, 6, 8, 10, 12, 9, and 11. And so we do see that there's overlap. These three numbers, 8, 10, and 12, are in both sets A and B. So using that on the next page, the probability of A is, again, 6/12 or 1/2. The probability of B this time is 5/12. There are 5 elements in in B. The probability that event A and B happens is that's the overlap here. That is 3 out of 12, or 1/4. And the probability of A or B from the Venn diagram is, let's see, altogether the union of these is 1, 2, 3, 4, 5, 6, 7, 8 twelfths, or 2/3. And now part F, the probability of A is 1/2. I'm going to call it 6/12. The probability of B is 5/12. The probability of A and B is 3/12. And so the probability of A plus the probability of B, that's 6/12 plus 5/12 minus, so that would be altogether, that would be 11/12. Subtract 3/12 gives us 8/12, which is the probability of A or the probability of B. And so that result is right here in the next theorem box that I have highlighted in yellow. So remember when we said if events are mutually exclusive, we said the probability of A or B was just the probability of A plus the probability of B. That was for mutually exclusive. So we see this is slightly different now when they're not mutually exclusive. If the events are overlapping, the probability of A or B is the same thing as what we got before, but then you have to subtract the overlap. Okay, in fact, this formula will work in all cases, whether it's mutually exclusive or not, because if they are mutually exclusive, then this part would just simply be 0. So that it's okay to use this formula in all situations, whether they're mutually exclusive or overlapping. So if there is no overlap, you would just be subtracting 0. So this is a more important rule to memorize. So or, you can still think of or as addition, but then you have to subtract the overlap. Okay, so here's an example of a chart that shows the composition of boys and girls in freshman, sophomore, junior, and senior at a school. And so if we want the probability of senior or girl, according to this formula, the probability of senior or girl is the probability of senior plus the probability of girl minus the overlap, which is the probability of a senior girl. And so the probability of a senior, there are 202 out of 808. Girls, there are 412 plus 808. And then we just have to subtract the overlap. There are 108 senior girls. And so if we do that subtraction, or addition and subtraction, 202 plus 412 minus 108, since they all have the same denominators, is 506 divided by 808. And that, if we do 506 divided by 808, that reduces to 253 over 404, or about 62.6%. Okay, so if you go on to the next page, you see they got the same answer and showed the same steps. Okay. So we can also do this one together. So this chart shows us the frequency of late and on-time flights and domestic and international flights. And so if we want the probability of the complement of domestic or late, so basically that's saying not domestic or late, first we need to calculate the probability of domestic or late. So probability of domestic or late would be probability of domestic 120 out of 180. I'm going to leave it. I'm not going to simplify that, so I'm going to just leave that blank. The probability of late is 18 from here out of 180. The reason why I'm not simplifying them is because it's going to be easier to add and subtract these if we leave the same denominator. The probability of both domestic and late is 12 out of 180. And then if we use the rule, this is going to be 120 out of 180 plus 18 out of 180, subtract 12 out of 180, and that is 126 out of 180, which is also 7/10 or 70%. And so remember, we originally wanted the complement of that. So we know that domestic or late, the probability of domestic or late plus the complement of domestic or late would have to be 100%. So if we want the probability of the complement, we can just do 1 minus 7/10, which would be 3/10 or 30%. Okay, at the top of page 1123, problem number 5, go ahead and pause your video and try out number 5, and then press play when you're ready to check your solution. So to find the probability of headache or no medicine, we want the probability of headache plus the probability of no medicine minus the probability of headache and no medicine. And so that's going to be the probability of headache is 27 out of 100. Probability of no medicine is 40 out of 100. And then the overlap, let's see. Yeah, the overlap is 15. People that got a headache and took no medicine is 15 out of 100. And so then that is 52 out of 100, or 13 out of 25. Or 52%, and that's it for problem 5. And I think that's it. So have a great day, everybody. See me in office hours if you need any help with this stuff.